How stars are born. Stars, the radiant beacons of the night sky, don't simply appear. They are born from colossal clouds of gas and dust, vast stellar nurseries scattered throughout galaxies. These clouds, primarily composed of hydrogen and helium, are known as nebulae. Within these nebulae, gravity begins its work. It draws together pockets of denser material, initiating a process that will ultimately lead to the birth of a star. These denser regions are the seeds of future stars. As gravity pulls more and more gas and dust into these pockets, they begin to collapse. The collapsing material heats up as its density increases. This is due to the conversion of gravitational potential energy into thermal energy. The core of the collapsing cloud becomes increasingly hot and dense. It forms a protostar, a prestellar object that is not yet hot enough to initiate nuclear fusion. The protostar continues to accrete material from the surrounding nebula. Over millions of years, the protostar continues to grow. Its core temperature rises relentlessly. Eventually, the core reaches a critical temperature of about 10 million degrees Celsius. At this temperature, nuclear fusion ignites. Hydrogen atoms begin to fuse together to form helium, releasing tremendous amounts of energy. This marks the birth of a true star. The energy released by nuclear fusion creates outward pressure. This pressure balances the inward pull of gravity, establishing a state of equilibrium. The star enters the main sequence phase of its life. During this phase, the star shines steadily for billions of years. It converts hydrogen into helium in its core, maintaining a stable temperature and luminosity. Our Sun is currently in its main sequence phase. The mass of a star determines its lifespan and eventual fate. Massive stars burn through their fuel much faster than smaller stars. They have shorter, more dramatic lives. Smaller stars like our Sun live much longer. They burn their fuel slowly and steadily, shining for billions of years. Their eventual fate is to become white dwarfs. The journey from a diffuse cloud of gas and dust to a shining star is a testament to the power of gravity and nuclear fusion. It is a process that has been repeating itself throughout the universe for billions of years. Each star that is born enriches the cosmos. It contributes to the ongoing cycle of stellar birth and death. The elements forged in the hearts of stars are eventually scattered back into space, becoming the building blocks for new stars and planets. The birth of a star is not an isolated event. It is part of a continuous cycle of creation and destruction. The universe is constantly evolving, with new stars being born and old stars dying. Understanding the process of star formation helps us to understand our place in the universe. It reveals the intricate connections between all things, from the smallest atoms to the largest galaxies. The story of star birth is the story of the universe itself.